I'm James Long. I work on the Firefox Dev Tools, and I've been thinking a lot about how we can improve our code. So I'm going to talk about some ideas about this. And just a disclaimer, these are ideas. We aren't actually running this in production yet, but we have some of it implemented, and we are about to land it soon. And also, a lot of these things are just things that I would like to personally see. So I don't completely speak for my team, but I think a lot of them seem to be excited about it as well. So there's this idea of tar in software. This is something that the Mythical Man Month book talks about, and Out of the Tar Pit paper, which is a fantastic paper. And I think especially if you've been working with software for more than a few years, this really resonates with you. Because it's just super, super frustrating when you want to do something small, when you want to fix a small bug, that 5 other things break that were completely unrelated to you. And it kind of is demoralizing, and it's a pretty dangerous thing. So of course, every piece of software has tar. Every piece of software has incidental complexity. But I think it's extremely important that we find time to clean our projects. And this, it's totally a project by project basis about how much incidental complexity that you're willing to kind of endure. But for us, I think we've, at least for parts of our code, we just have too much. We can move too slowly. So some of the things I'm going to talk about are how we can move more quickly. So we've accomplished a lot in the last few years. It's really amazing what the DevTools team has done. Yeah, the web console does not source map line numbers yet, so I'm really sorry about that. But we're going to fix that extremely soon. But we haven't said undefined is not a function for years. So I mean. Chrome, was really late in the game for that. So I don't know if any of you all were in Richard Feldman's talk about Elm, and that was like his big complaint that like JavaScript says undefined is not a function. But if he had just used Firefox, it would have been fine. But we've been too busy to really improve how our UIs work, how our front end code works. So I've been thinking about our UIs a lot. One of the main problems is that we use Zool. And Zool is a technology that the Firefox UI is based on. And Zool is basically HTML's grandma. It's just old, and it doesn't really understand what's going on all the time. I mean, it's a part of the Firefox code base that really isn't worked on anymore. There's these really weird bugs, and so that's a really annoying problem about our UIs. So we're working on getting off of that. There's actually a painter named Zool Solar who makes these paintings, and I think it depicts Zool pretty well. Just how I feel about this every day. So it's not really the main problem, though. The underlying problem is that we do a lot of mutation in our UIs. And we have state in a lot of different places, and it's just really hard to figure out what's going on. Now, this isn't specifically Zool's problem. This is, HTML has the exact same model. And it was okay, maybe 4 to 5 years ago, but the landscape of UI work has really drastically changed. So, this is our UI right now in a lot of our tools. It's pretty bad. It's pretty messy. Not only do we mutate state, but like everything calls out to everything else, and it's kind of a pain. There's a few tools that are newer, like the performance tool, and it's a lot more well written, and the code is a lot more straightforward. But it still mutates state, and it still doesn't enforce as much of a structure, at least as much as I would like to see. And lastly, it doesn't use React, so it doesn't use the React component models. So I think it's harder to share components around. So I think we can do better. I want to treat state as an explicit object. And this means that our UI is something that we don't mutate. This is something that we just pass our state into, and we just generate a new UI. And this impacts a lot of the overall architecture. All of the other layers sort of become simpler when you have this model. Because your UI is just a collection of pure functions at this point. React is really key in this because React is the thing that actually allows us to express our UI in this way. Because normally the only thing that you can work with in the DOM if you want to make changes on the screen is to call a DOM method to mutate the value. But React kind of papers over all those problems and gives us a pure functional interface. This is what a lot of current apps look like. This is the sort of familiar MVC model. Models sort of manage their own state separately. Views kind of manage their state as well, like a selected item or something like that. So the state is all kind of separated out. What if instead we combined it into a single atom? This is just an actual single object. And this is called a single atom app state. And just imagine all of the state that you saw in the previous slide sort of rooted onto this object. So now there's a path to all of the state in our object if you have a handle to this single atom app state. This works because it turns out a lot of UI needs any access to your app state anyway. You don't know which pieces of app state that a specific UI piece depends on. It can sort of query into the UI app state, right? So all of this state is sort of global in the UI world anyway. And when I say global, don't think of global as in global variable. Think of it more as just a database. This is like a database that you can query. We don't actually use an actual database with a query language, but you actually could. There's things like DataScript or like front-end in-memory databases that you could actually use as your app state if you have more complex models. So global just means that it's just accessible in a way. If you have a handle to this app state, you can access the properties within it. But we can still restrict the actual how we pass around this app state so that certain things don't actually have access to it. So now we can do all sorts of cool things. What if we don't mutate this object, right? And we actually return a new state every time we want to update it. And this means that whenever we want to look at the UI at a certain time, we can just keep a reference to that app state. So we can actually walk back in time and see what the UI looked like at that exact point in time. So we can walk back and forth, not just walking back and forth, but we can also just look at the UI at any point in time. We can literally just grab this app state and throw it into our UI because our UI is just a pure render function. So once you start doing stuff with immutability, I mean, you just really don't want to go back to mutability. I mean, it's just like, you start just like, what in the world is going on? So that's the essential idea. I'm going to show you this actually working. So I've rewritten parts of our UI to use this. So this is the debugger UI. This is just the debugger. And first off, I can do some actions. And I can grab that single atom app state by calling getState. So this right here, this object, is the entire representation of my UI. So I set some breakpoints, right? If I click on this breakpoints object, you can see within the breakpoints, there are 3 breakpoints. That's exactly what is shown in the UI. So I can look in the location. I can see that this is on the source actor, and it's on line 3. So if I removed a breakpoint, I could look at the app state again, look into the breakpoints, and see that that breakpoint is gone. I don't care about the actual DOM anymore. I just care about this normal JavaScript object. And it's just like extremely refreshing to not have to do weird CSS queries just to check certain state. So we've got to pull state out of the DOM. It's a terrible place to put state. Additionally, because we never mutate state, I can actually do some more actions. I can change the source. I can turn off breakpoints. Because we never mutate the state, I can just keep a reference to all the past app states, which I've done. I can pull up this little slider and just scrub past all of my app states in my entire app. So at any point in time, I'm looking at the UI. And what's super interesting about this is that you can see a lot of things. Like when I disabled all of the breakpoints with that button, I can actually see that it disabled one at a time. So I can see, for asynchronous work, I can see exactly what has changed in the app state. And so maybe I want to do it this way, or maybe I actually meant to do it all in one single app state change. But for some reason, it's doing in multiple app state changes. And it's super easy to rationalize about the app state changes now, because I can just show it over the exact amount of time that I want to. So not only that, but I can show you, just to drive this point home, this is the entire amount of code to have a record and replay functionality. So I have record, which just basically says whenever the state changes, I'm just going to push it onto this array. And then I have a stop record function, and then I have a replay function. And so the replay is just going to asynchronously iterate over that history. So every 100 milliseconds, it's going to dump that app state at that point in time into the UI. So if I run this and, let's just make a new instance and run this, and then I'll just say start record, and I can make some functions, or make some actions, change some stuff, and then I can come down here and just hit replay. And this is all in userland. Just because I'm not mutating the app state, I can do all of this in userland. So think of any sort of debugging that you would want, and this is just kind of all comes for free. So that's pretty cool, right? So how is this possible? Well, it's all about avoiding mutations. And there's really two pieces, the first of which is React. So the problem is that using the DOM is side effecting. So React obviously gives us the pure render function as I've described. So sometimes I like to think of the DOM as like Mount DOM. It's just this like terrible place that you don't want to go to, but you have to. So this is what you're basically doing when you're working with the DOM directly. You have to implement the state changes yourself. When a state changes to change it in the DOM, you actually have to think about the diff of state 1 and state 2 and add an item or remove an item. So it's just really not a great way to, a great way to think about it. So React gives us this pure functional render function. And so there's a second piece, and the second piece is a library called Redux, which actually implements the single atom app state. It was started by Dan Abramov, but it's a collection of ideas from a bunch of other languages. It's a really great library because it allows us to have the single atom app state and a common method for updating it. So it takes ideas from many other places, such as the single atom app state from ClojureScript. ClojureScript was really the initial language that pioneered this. Actions from Flux to represent changes in the app state. So you fire an action, and that represents a change. And then an update function, and this sort of comes from Elm, where the update function takes a state and takes an action and returns new state. So you can take whatever action you want to and then return some new state. Those are the three parts. So really, you have this workflow. You have this state object. When the state object changes, the UI re-renders, and then the UI can fire actions through action creators. And the update functions can take actions and change the state. When the state changes, the UI renders. So there's this very, very simple, clear circular flow. This is actually very similar to how Elm works in general in their front-end code. So really, at this point, the only thing that Elm gives you is the static typing. So this is an example of an action. This is just a JavaScript object. And you call a dispatch function. So the dispatch function, you don't really care where it came from. I can't really explain where it comes from, but you have a way to kind of bind to a dispatch function. And you just call dispatch, and you can dispatch an object. And it has a type, and it has, so this is just saying, I want to add a breakpoint at URL foo.js and line 5. And then you have update functions, which have a couple interesting aspects. So they take a state and they take an action. So one interesting thing is we're using, this is sort of enforced by Redux, but Redux allows you to specify the initial state just by using the JavaScript default parameter syntax. So this, when you kind of bind an update function to the app state, Redux will fire an action with an undefined state throughout your entire update functions. And so this will, by default, just be bound to the initial state, and then you won't handle the action, and then you'll return the initial state. So we can always get the initial state of the entire app, just like by running undefined through our update functions. And so this is kind of co-locating the initial state with the actual state changes. And the other thing here is probably the most important part is here we just have a switch statement on an action.type. And some people kind of react to a switch statement and be like, oh, that's ugly. Like, why don't you just use multi-method dispatch and all this stuff? It really turns out that these update functions usually end up, even in my most complex code, it's really about 100 lines of JavaScript. It's not worth it to me to really break up these update functions, because really these update functions, the whole point of them is that they are getting all of the actions coming through the system. So you're supposed to be able to handle it like any single action, and that's a super helpful property of this system because you can react to anything. So if you're supposed to show a count of something that happened over there, like you know that you're going to get that action too. So we just switch on the action type. It works fine. I mean, if you really want to, you can create helper methods or something too. But the other important thing to note is that we always return new state. So here we're creating a new array and adding the new breakpoint with the URL and line onto it. And obviously, if you have this big complex app, you're not going to want to manage everything in one update function. So it's super easy just to modular, have more modular update functions that kind of handle subtrees of the app state. Here I'm manually doing it, where I'm manually kind of passing off to other update functions like the source and breakpoints. But Redux does it so that you can actually have these separate update functions and then kind of automatically combine them into one update function that automatically calls all of the other update functions, and it just creates this top level app state for you. So that's pretty cool. So here's a demo of the actions in play. Let's see, I already have this running. Okay, so actually I want to, let's see. So this architecture is very nice for debugging, because I can just come in here and I can just say, let's log all of the actions coming through. And for reasons I want to explain, I have to build it. So here we're going to see every single action coming through the system. And because actions are the only way to update something, that means that I'm seeing the entire transactional log of changes, of course. All right. So here's my UI again. Now I'm logging every single action. So if I pull up the console, so there are already some actions. Those are the things that happen to initialize the UI. So if I set a breakpoint, you see there's an add breakpoint. There's actually two, because it's an asynchronous request, and it's firing one at the beginning and one at the end. So if I change the source, you can see that there's a select source option. And you can see all of the parameters here, right? So this source is an object that this is the source that I selected. So this entire log right here this is everything that has happened in my system. This is just like super nice to see. If you're trying to run tests or you're trying to figure out something that happened wrong, then you can just pull this up. And for just another demo, this is the same replay code, except this time what I'm doing is I'm starting to record all of the actions. So here I'm going to record in the app state at a certain point in time, and then I'm going to record all of the actions after that app state. And then in my replay, I'm going to replace the state with the state that I started on, and then I'm going to replay every single action. So this is kind of similar to the time travel debugging with the app state, but what's different about it is that I can actually see the changes, see why the app state changed. All right, so let's run this, and let's clear this and say record. Oh. Say record. So now I'm going to do some stuff. Let's make this smaller. Now if I replay, let's clear this again. If I replay, it does the same replay functionality, except now I see all of the actions here. This is the thing that replayed, and I'm also logging the actions, so it's duplicating that. But if I were to say be running a test, I could just have this, and I could pull that down and replay it. In fact, let me just show you that I can do that. I'm just going to serialize that initial app state and then all of those actions into this string. I'm going to just close Firefox, and then I'm going to run it again. Go to my debugger, and I'm going to paste that app state. And so this is the point in my UI that was that I saved all of that stuff. But I can pull up my slider again and slide it back and see everything that happened. So it doesn't matter if it's not tied to that instance of my debugger at all. It contains all of the information for replaying the app state. So if somebody wanted to file a bug report, what my goal is, I can say, hey, hit this special combo of keys and send me that zip file, and it's going to contain their entire, or maybe the last 100 actions or something, and you can see exactly how the UI built up to that point. You get all this for free, the single item app state, and just don't mutate it. I mean, it turns out that that's just kind of good software anyway, and this is just kind of a side effect of just writing better code. Okay. Sorry. So there's a Redux Dev Tools that I couldn't get working quite yet, but they actually show all the actions in this really pretty pane. And not only does it show the actions, but it shows the action and the state at that point in time. And you can actually click on actions to disable them. And so it will replay all the actions and skip that one. So you can kind of see what happens when you don't play that action. It's really, really cool. OK, so how in the world did I go from this to that without a total rewrite? Because a total rewrite is just not an option. Well, the first thing I did was I looked at this update function. And so there are these state changes, right? So how do I, the plot twist is that I'm actually not using React yet. I'm just using Redux. And so how do I go from these state changes, how do I tell my mutation-based UI to make these state changes, right? Because when this update function is done, it just has a whole new state. I don't know, my mutation-based UI needs to know exactly what has changed. Well, let's restructure this just a little bit. Let's assign the breakpoints to a variable. So now I have the BP variable to work with. And I do something horrible. Like, don't do this unless you're migrating code. But I emit events that are specific to my state changes. And it makes the code a good bit more like verbose and annoying. But I have to do this because my UI, my mutation-based UI, has to know what has changed, right? So this violates all of the constraints and contracts that like Redux is trying to enforce on you. So I can do this because you can see that there's a third argument emit. So I've like wrapped all of my update functions and added that third argument. So this is not a normal Redux emitter. Again, don't do this at home unless you're migrating code and committing to migrating that code in a couple months. So yeah, so we're hoping that like in a while, if we start using React more, that all of this code just kind of goes away. So I'm really interested about migrating existing code because a lot of us right here in this room are probably working on code bases that we would like to use cool ideas, but we just can't because there's just it seems overwhelming to how do you change that enough to actually start implementing these ideas? Because rewrite in React and Redux seems like a total rewrite. But as you've seen, if you are able to violate constraints here and there, sometimes you can kind of limp along to get a pretty good migration path. So this is kind of what we're going for. We have this single atom app state. We have a UI with these views that can fire actions through action creators. But as we saw, our UI is still our old UI system. So this is mutation-based UI system. So we actually have to fire events. And this is just a temporary measure. So after the first, I kind of like to think of it as several passes of migration. So after the first pass, this is sort of what the code base looks like. We're still reusing a lot of the old code. We're using all of the old UI system. And we're converting controllers into, like, the controllers are the thing that we're mainly focusing right now, where we're converting them into action creators. And like the state update functions, they kind of are split into two things. But we're able to reuse some of the complex business logic that are in the controllers. You can see in the action creators, those reuse some of the really complex business logic to figure out like where to add a breakpoint and like when to do it at certain times. I was able to just copy those code over and just kind of clean out all of this old other junky async stuff. And there's still controllers in there that haven't been converted, but this is working. Like this is just kind of sitting side by side. And so eventually we would like to convert all the controllers so that everything is an action creator, everything is a state update function. And then what I would like to do is eventually use React so that we can just pass that state into the React component and we don't have to worry about any of that code. So that's the goal. What's interesting about this is this not using React but using Redux has really highlighted for me the benefits of React. Because there's things like this that we have to implement that we wouldn't have to implement without React. There's all these empty functions which kind of clear out that current UI element, which it just says like set me back to a default state where I had no data. If you use React, you don't have to do this at all. You just render based on the state, and if React needs to remove things from the DOM, then it will automatically. And this is important. So like the DevTools is kind of weird because we frequently have to empty our UI out. So if you like refresh the page or if you navigate away, we empty the whole UI out because the DevTools is still the same instance, right? So all of the data is emptied out of the UI, and then the new data from the new page is loaded in, like the new sources and the new breakpoints and stuff like that. So we do this every single time that you navigate. So we have to, every single one of our UI widgets has to know how to empty. And there's There's some abstractions that try to paper over this and make it a little bit better, but at the end it's still mutating the DOM, and we run into race conditions all the time. So another thing that we wouldn't have to implement if we use React. So currently I'm taking state and I'm able to dump it in at any arbitrary time. So how does that work with our mutation-based UI? Like I could see how you could go from one point in time to the next point in time, because as you made those changes in the update function would emit those events to change the state at each point in time. But how do I, with our mutation-based UI, how do I arbitrarily load in state at any point in time? Again, it's the horrible violation of everything. By basically, I empty out the entire UI, I call all of those empty functions, which we already have, and then I fire a special action type, which is reload. And so every single update function has to implement this reload action type, and it basically has to emit events that will build up the UI that should theoretically represent the current state. And obviously, this is like horribly fickle, and you have to be very aware of the internals of how your UI works and like which things are handling event handlers in which order. It's just super hard, right? But with React, you don't even need this code at all. This is all the event emitter stuff so that we can empty out stuff and then like load a new state. Of course, obviously it's working as I showed you in my demo, but it's more incidental complexity that I don't really think that we need. Okay, so let's talk about action creators a little bit. This is an action creator. It's just a function that returns an action. And that, when you hook things up, this is bound to a dispatcher. So like when you call it, it's actually automatically dispatched. But it's really, when you want to test stuff, you want to keep these just things as just pure functions, right? You can also return a function which takes a dispatch and a get state. So you can manually call dispatch yourself. And this is helpful because you can do stuff like asynchronous work. So here I'm dispatching twice. I'm dispatching first when it's started, which lets me do things like optimistic updates. And then I'm calling the like add breakpoint function. And then at the end, I'm saying, OK, I'm done, and here's the value. So actually, that's why you saw 2 breakpoint actions going through the system. And so this is really, really nice because the action creators are the place that you should be doing async work. And async work is terrible. And it's really, really nice. I found it super nice that there's only one place that you can do async work. There's been a lot of talks at Strange Loop about effects, and that's basically what we're doing. We're isolating like side effects into one place. All of the other stuff on the right side that's synchronous, it's like synchronous pure render functions, right? I mean, that's all it is. So the action creators tend to be somewhat bigger because that's where some of the complex like business logic is. But the right side still tends to be, at least in my experience, like 60% of your code, maybe 70% of your code. So to have the majority of your code, especially your whole UI, it's just like a normal synchronous thing that doesn't do any async work I've found super, super freeing. It just makes testing a whole lot easier and things like that. In fact, oh yeah, and I was going to say also, like this is, I think promises and observables and channels and any async abstraction, they belong in the action creators. You don't need any of those for your entire application architecture. A simple pub sub style thing, which is basically what, well, I mean, it's not even really pub sub anymore, just like a dispatcher function that is one entry point where things can kind of like listen to the actions is really all you need, at least in my experience. Because async abstractions, I also find them just kind of just a bear to work with, like promises. Like promises and errors, like what is up with that? Like, I mean, especially in JavaScript, like you make a typo and you forget to like add an error handler to the promise and you're screwed, right? Or like tools should save the problem, right? That's what everybody says, except what happens when the tool breaks on your tests and when your test is failing, but you actually had no idea because the promise was eating the error. I mean, this happens all the time to people that I would talk to who work with promises, and it happens with us in our tests too. So, I'm definitely ranting about promises, but I have to do stuff like this. Like I'm done with my async work. You don't care about the errors in my UI. I just want to continue on with my synchronous world. So, but I can't do that in promises. I literally have to do a set timeout of 0 to get out of the error handling. So I like the async abstractions. They're great for like an error happens and you retry something 10 times. That's great, but don't force it in my whole entire UI, right? So this is great because if I make an error in my UI, like shows up in my console, I can break on exception. It's great. You would think that would be a normal thing. So these are a lot of cool ideas. There's a lot of work already done with this. Redux is essentially just a combination of a bunch of other stuff, and there's like was the Closure framework written by David Nolan that did like the single atom app state and base everything around that. There's Elm effects, which I talked about, which is basically Elm. You don't actually ever have side effects. You actually describe what that side effect should be, and it's passed up into the global like runtime. Then the runtime actually does the side effects. So now that all of our side effects are in ActionCreators, maybe we can talk about like, hey, maybe we shouldn't actually be doing the effect literally in the ActionCreator. We can like delay it into some description of the ActionCreator so that we can test it, right? Because ActionCreators are the last thing that are still kind of hard to test. And then there's Relay and Falcor, which are kind of a different beast. They're more focused on like when you have a super complex backend database and you want to do complex queries on the front end, and you don't really want to care. The front end doesn't really want to care about what's loaded on the client or the server. Our data tends to be relatively simple, so there's not really much that I don't think that we can learn from that. You know, testing. This is like another side effect of writing, pun not intended, of writing just pure functions. If you have pure functions and modules, just all these things sort of fall out of it. So this is our this is a view into how we do testing in Firefox. It looks like really, I'm just realizing now that I understand this, but you probably have no idea what it is. It's like looking at the matrix. But so this is we call it like the try server, and the orange boxes are failures. And so when you make a change, you want to push to our try server, which is this massive infrastructure which runs it on different platforms and different optimization levels. So you can make a change and really legitimately see it run on all kinds of cool stuff. And so the orange things are failures, and so when you have a bunch of failures, we call it, you know, you're burning the tree because it really looks like everything's on flames. It's really awesome. So testing is not fun on the try server, because if there's an intermittent test that only fails 1 out of every 10 times on Linux debug, I mean, I'm telling you, it's like the worst thing to debug. Everyone, when we realize we have to debug that, we all just like sigh. But if you have these pure functions, I mean, the first thing is that a lot of our UI tests require the DOM. So we essentially have this test called a Moki test, which it fires up a whole DOM instance and runs through some stuff and then ends. And doing that just tends to be sort of race conditioning. I mean, when you actually have to rely on a real DOM existing, it just tends to be a lot harder. So if you have these pure functions, like this update function, it's just a pure function, right? You can just call it. And the result is something that you can just test. So I can say, oh, like the initial state of this update function is 0, or of x is 0. When I pass increment x to this, and x is 5 in this state, x is 6. I mean, it's a very easy testing. So when we end up using React, there's also a whole lot of things that we can do with React, and this is even more powerful in my opinion. I'm super excited about this because when we have React components, React has a shallow renderer. You can create the shallow renderer, you can import your component, and you can render it with the shallow renderer with some state. And then you just call get render output, and you have this whole description of what the UI should be. It's just this kind of sort of JSON-y description of the whole entire UI. And you can do all sorts of complex tests on it. There's no DOM required. So we could actually run all of these in just a JavaScript shell test, which is just far, far faster. So there's minimal async, no DOM interactions, and it's just really fast and easy tests. So I had this idea, and this is the last thing that I was going to talk about mainly. So we have this app state, right? It's just this like single object. I was playing around with generative testing. I was like, what if, like, we have this single app state. What if we sort of described it in types, in like a gen test style type? Could we actually generate app states and just do property-based testing on it? So I did this. So this is gen test. So I'm describing my app state in types. So the source ops, the line is a non-negative. The source type, there's an actor URL. It's a string such that it's greater than 0. And then I run this. So if I run this is just like dumping out app states and as fast as it can, just like throwing it in the UI. And it actually is erroring out in the background. I'm not going to show you the errors, but because our UI is kind of weird. And part of it is probably the fact that gen tests is kind of weird too. Like I have to make sure that I'm generating valid app states. If I generate an invalid app state, of course it's going to error out. But I can pull up the slider, and I can run through all of the tests that gen test threw into here. So I don't really know if this is actually that useful, but I just think it's super cool just to be like, oh, cool, like UI, multiple UIs all the time. I don't know. I thought this was cool. I don't know if I'm actually going to get much from this. So I don't know if that's really going to work out. But it's a cool idea. There's cool things that you might be able to do, like make sure that this is checked when this is highlighted. If you have certain, that's what the property-based testing is. That after you generate something, that you test the properties of the generated structure. So there's a lot of stuff we have to do, like migrating to React, choosing which immutable library. I don't have time to talk about it, but right now I'm using Seamless Immutable, which is it doesn't do the structural sharing that Immutable.js does, but it integrates a lot better with the other JavaScript function. And then there's hot reloading. So pure functions are super easy to hot reload. So we should be able to get it to work, but when we save a function, it's immediately running in the live app. There are a bunch of challenges to this too. Like there's component local state, which I haven't talked about. So far we have this global app state structure, which is appropriate for a lot of things. But there's a lot of things that component local state is appropriate for too. And I don't have time to really talk about it, but essentially it doesn't really, we should be able to use local app state. The only problem with local state is basically because it's wrapped up in the component and not connected to the global app state, that you can't do the record and replay. But you actually can. That's just a technical problem. There's no reason why you shouldn't be able to back the local state into that global app state atom. That's what Circle CI did, if any of you all saw that post. So it's really just a technical problem about where that state is actually backed in the component local state. There's no reason why we shouldn't be able to have state in the global app state that's only scoped for a component. So I think the idea of this single app state doesn't necessarily mean it's even global. And lastly, there's places where we need to abstract the data queries out because we have this now, like we're passing state directly to like a UI. So if it says like .source.line, if we ever wanted to like change the data structure, that means that some of those things will break because they're assuming a certain data structure of the app state, right? So I actually have a bunch of functions that are like get source, and I give it the URL and it will get the source object. And that way I can change around the data structure. But it's a little bit weird. I mean, that is one downside to it, is that you have to have you basically have to run, essentially it's just like functions as queries. Like you could think of it as like querying a database again. Not sure if that's a bad or great thing, but I think it works right. So that's a quick overview of where we are at. So it's still a bunch of research, but it's been a lot of fun. I think we're going to do a lot of cool stuff with it. So I have a few minutes for questions. Yes?
Are you capturing the DOM as part of your immutable state? And so do you have a persistent data structure within the DOM? Or is that what you talk about the features of going to immutable?
Well, the DOM at this point is, so the question was, are we capturing the DOM as state? Is that right? So the DOM at this point is just the low-level rendering, right? The state is just a JavaScript object. I mean, and we just assume that React is going to take that state, make the DOM reflect exactly what that state is. We don't store any state in the DOM. Does that make sense?
Well, you're manipulating the DOM, but that's not part of what stores your state when you do the replay. Right?
Yeah, right. Yeah. Jason?
So, can you fire up Firefox one more time?
This?
Yeah. So it's maybe not entirely clear to everybody. So first of all, can anybody just type this URL?
So not yet, but so I've hacked it. So yeah, gosh, this is going to be weird. Let me just, so that I don't have two debuggers open, that would be weird. So yeah, this is the same debugger. I made it so that I could load our internal tools, which are backed by this Zool file, into a URL. And if you're not loading it in the dev tools itself, it will populate it with just some mock data. So that's what I did. No, but you can do that maybe after we land this, but right now you can't do that because you could load that XUL file, and you would see the basic debugger interface, but you see a bunch of errors because it assumes that it's running in the DevTools. Yeah, well, I have a mock thing that just is populating it with mock state, yeah. But this is like real state, and if the actions are still here, yeah. So yeah, I just mocked it out so that I could work with it in here. And what's really nice about working it with here is that I can use the normal console and stuff like that, where if I work with it in the actual DevTools, we have like a browser console. And does that make sense?
So what's happening here? So when you do everything super fast. So when you click.
Sorry.
So right now what we're looking at is one instance of the DevTools, and then you're opening up another instance.
Yes.
Okay.
So this is one instance of the DevTools. This is just like it has mock data in it. Sorry if I should have explained that. And then this is our second. So I mean, we use DevTools to debug the DevTools all the time. So I'm probably more used to that than you guys are. Oh wait, just wait. There's a third instance of DevTools that I can open up here. So there's a browser toolbox that we use to actually debug the actual UI. So sometimes we even have a third instance. We can come in here and inspect the DevTools and say, oh, here's this button, and here's all this XUL stuff. Yeah, I should have explained that at the beginning. My bad. I'll take one more question, maybe. Yeah. Is there anything apart from time that's stopping me from rendering with React? No, it's just that's like the second migration step, and this is the first one because I'm not sure if I explained that as well either. But essentially, with that really messy architecture, I realized that we really had to clean up everything first before we could use React. React integrates really nicely with systems, but it kind of also has to. Your views have to be isolated, and our views were like touching everything, and so to clean up what was touching each other, I essentially realized was implementing kind of like a Redux style thing. But I hope to use React. We're still talking about it on the team, so I'm not really like announcing we're rewriting everything in React because we can't rewrite stuff. But it's just time to figure out where to use React, and I hope we use React in a lot of stuff. Yeah.
Do you ever have volunteers come and contribute patches to DevTools?
Do we have volunteers or contributors? Yes, we absolutely do, and I'm hoping that when we use React, we'll have a lot more people in the React community contribute to. Yeah, we definitely have a decent amount of contribute. I don't have like numbers for you, but part of the goal of this is to make things more sane so that you can come in and just like make a change and things don't break. Because right now it just is a little fickle. So if you want to contribute, come talk to me for sure. So, all right, I think I'm out of time. Thank you all.